Hello dear students, how are you? Previously we were learning loops and we have learned the concept of flags and how it is very useful when we have a condition inside a while loop and we want to test it whether this condition is true or not. For example, here we have an example of a prime number. In this we have a flag variable called is prime. The value is true. That means we are assuming that the number is true, and then we are changing the value of is prime to false, right? So at the end, after the execution of a complete loop, we can check the status of this is prime and find out whether the number is prime or not. And on that day I have given you a task that says you have to find out all the numbers or all the Armstrong numbers between 10 to 20,000. Is there any number or not programmatically? So let us first do the task or divide this task into small steps. Okay, so my task is to find out whether the number is prime Armstrong or not. Armstrong number. Okay, so for this we should know what are Armstrong numbers. So Armstrong numbers are the numbers which are when calculated like this. For example, we take out the individual digits of the number and we cube it and then sum it. For example, we have a 153. If we calculate it in this fashion, 1 cube is equals to 1 and 5 cube is equals to 125 and 3q is equals to 27. If we add 125 and 27, it will give you how much? 153 again. So such numbers are called Armstrong number. Now students, I would like to tell you that please do not simply write your program into your copy, because whenever we do that, we do not do a dry run or debug it, you can say that, and in that case there is a strong probability that that program will not result into proper you can say solution for the problem, right? So we are going to try it. So first thing first of all, we have to find a means and ways to segregate all these three digits. For this we have learned a program, and that was what we need to do. We have a number is equals to 153, let's say, and I want to segregate all the digits from it. So what I used to do is, first of all, I'm going to print the number and modulate take out the modulus with 10, and then I'm going to reduce this number by dividing to 10. Okay, let's correct the variable name. Okay, now I'm going to execute this piece of a code and check out the result, and this will give you a fair idea how it is being worked out. Okay, so I have to select 3 lines, then let us execute this. So I'm getting a 3. Now why I'm getting 3, let's find out. So I have printed number modulus 10, that will give you a remainder, that is 153 modulus 10, this will give you 3. Okay, so that's why I'm getting 3. But now let us print out the number after reducing it, right? So let's select all, Control Shift E, and you get 15 from this statement. So here why 15? Because if we divide by 10, we are getting 15.3, and actually this is an integer division. That's why we are getting only integer part by simply removing the decimal part. So that's why we are getting 15, and here also you can see I'm getting 15, number is equals to 15. Okay, so now let's progress. Now what we need to do, we need to take out the modulus by 10 so that we get 5. Okay, so now this statement is going to print and give me 5. Okay, let's select it all and execute it. Now you can see I'm getting 3 and 5, right? So finally, if I reduce it to one more time, number divided by 10, and print out this number this time, let's select all and execute this. So now you are getting 3, 5 and 1. And if I reduce it further, now I should be getting 0. Okay, so let's print this number, print number, and let's execute this piece of our code. See, so what we are getting 3, 5, 1 and 0, right? So at the end we should be getting 0. For example, if we have a 4-digit number, we have to do it 4 times, and at the end we will be getting 0, right? Okay, so this is it. Now let us analyze this. What are the steps which we are repeating again and again, and when we are stopping? So initially we have a number called number is equals to 153, and we are reducing it. Okay, now incrementing or decrementing, we have talked about these steps, right? Let's make it a comment and see step. So this is the step. In our previous example, sometime I is equals to I plus 1 was the step. Is the step, okay? And sometime I is equals to I minus 1 may be the steps. So in this case, this is the step which is reducing our number till 0. Okay, so at this point here, let's make it a little bit bigger. At this point my number is becoming 0. Let's put a hash on it and say number is equals to 0 at this point if the digit in number is 3-digit number. Okay, now if the number is 2-digit, at that time we will be getting 0 here, and if the digit is 1-digit number, then we will be getting 0 here only. And if we have a 4-digit number, then we have to do it one more time, and finally we will be getting 0. So the bottom line is that we can repeat these steps till the number gets reduces to 0, right? So now this complete statements from here to here can be written under the while loop. Let's write a while loop and say till the number is greater than 0, right? And if the number is 0, then we are going to stop it. Let's make it inside the while loop, and let's get rid of all these, right? So now we have only 4 statements which are working for me in this program. Let's execute these programs and see I'm getting 351, right? So now I'm going to print the asterisk so that it is a little bit different and you can check it out. Okay, I have printed right now. Okay, so let's select all and execute this piece of our code. Now you can see I'm getting 3, 5 and 1. So I have achieved my first target to segregate all the digits. Now what I need to do is I need to accumulate these values. Now first of all I need to calculate the cube of this. So with that is very easy. What I am going to do is I'm going to store in, let's say, remainder is equals to n modulus 10. So now R will be holding 3 for the first time loop executes, or the ones place digits. Okay, and if I take another variable or simply print the cube R, let's say cube, this will print 27 for the first time, and then 125 and then 1. Okay, let's try this. Select all and execute this piece of code. So why I am getting 27? Because first time if we divide it by 10, we will be getting 3 as a remainder, and 3 multiplied by 3 multiplied by 3, we are getting 27. Similarly, 5 multiplied by 5 multiplied by 5, we are getting 125. So here I'm able to achieve my second target, that was to calculate a cube, right? Notice how I am making a solution. I'm not writing a complete program in one go. I'm analyzing the problem and I'm conquering these problems one by one. So first of all, I have divided my programs or my task into smaller tasks, and then one by one I am achieving it from bottom to the top, right? So now I need to accumulate it, just like we are reducing here. I need to accumulate this result into some variable and add the previous value to the current value. So what I'm going to do, initially we are saying s is equals to, let's say, 0, and here in place of a printing I'm going to use like this: sum is equals to r cube, and this is r cube. What I need to do, I need to sum it or accumulate it. So now finally what the expression is, s is equals to s plus r cube. So initially the value of s will be 0 and r is your 3. 3 cube is equals to 27, as you can see in your screen, and 27 plus 0 is equals to 27. So for the first time the value of s in the statement 7 will be 27, and for the next time when we are getting inside the loop for the second time, at that time the value of s will be 27 and r cube will be 125. So 127 plus 125 is equals to 152 for the second time, and then finally 1 is added. That's how we get a s is equals to 153. So now let us print the value of s here. Okay, so I'm printing the value of s here, and let's simply execute it. Then we can debug. Then we will debug and see how it is being calculated again, right? So select all and then execute it. So see, as I said, 1 to 27, since the value of s is equals to 0, 0 plus 27 is equals to 27. That's why we are printing 27 for s, and then 125 plus 27 is equals to 152, and then finally we are getting our desired result. So now what we are getting s is equals to 153 for the final time. So now let us see, if I say if number is equals to the s, that means this number s is equals to the original number that we have taken. Then if it is true, if this condition is true, we can say print the number is Armstrong number, let's say. Okay, else print the number is not an Armstrong number. Sorry for my spelling mistake, this should be G. Okay, and these are just typing errors. Okay, so now see, but if I execute this program as it is, it will not give the desired result. Now guess why? This is your homework. Why this is always giving the number is not an Armstrong number. This will be your task to find out. Okay, if I execute it, see, no matter what value I specify, the number is not in Armstrong is executed. Why it is so? See, 153 is the original value, and the value of s is 153. Still this statement doesn't work. The question is why? Okay, you have to send WhatsApp message or give me a response anyhow, right? So preferred answer will be on my WhatsApp number. You all know my WhatsApp number, right? So don't worry if you are just guessing. There will be no consequences, but try at least 10-20 times. Try to debug. I have taught you how to debug the program. So I hope you are ready for this challenge, and on the next day we will discuss why we are getting this string always. Let us now try one more time. If I reduce it 153, then also still I will get the same result. And for this number again, if I say let's change it to 153, and still I'm getting the Armstrong number. What's wrong with this program? You have to find out, right? This will be your task. Let's see whose message comes first, right? So goodbye for now. I'm expecting your answers, and when I'm giving you answers, sometime I know that you are not able to do it, so don't worry if you are wrong. This in this way we will be learning, right? Bye bye, see you.